Alright, in part 3, I'm going to show you how matrices can be used to create geometrical transformations. So we're going to start by drawing a simple shape and using a matrix to rotate it by 90 degrees in either direction, and eventually by any arbitrary angle that we want. There's a little bit of trigonometry in here, but it's nothing that you guys can't handle. Alright, so besides the example worked through in the project sheet, again, I thought it might be good to see another example, and that's what the next part of this is all about. Right, so I picked this weird looking shape drawn in red. You can follow it through A, B, C, D, E, F, G. It's a little bit of a spiral, right? It's all in the first quadrant. And I've just written down the coordinates of each of those points, A through G. X coordinate, Y coordinate, as always, X comma Y. Then I just took those points and I put them into the matrix big A. And the top row of that matrix is just the X coordinates of each point, right? 5, 1, 1, 5, 5, 2, 2. And just look back at the original points and how their X coordinates make that sequence. And the bottom row is the Y coordinates of those points. So a given column, say the third column, 1, 1, that's the coordinates of the point, the third point, C, 1, 1. Okay? And then the matrix R1, I've told you, is designed to rotate any shape, counterclockwise by 90 degrees. Okay? 0, negative 1, 1, 0. And let's see how that works. So we just do our matrix multiplication, and I don't need to see all the working out here, okay guys, for once, because it's really easy. It's either multiplying by 0, or by 1, or by negative 1. So the result of the multiplication is pretty easy to figure out. It's on the right there. You can see that what has happened is the rows have switched places, and the top row has become negative. Okay, and then using these arrows, I'm trying to show you that, again, each column corresponds to the position of a point. So, for example, the last column, which is the new position of point G, is negative 2, comma 2. Alright, then I've taken all those points from my result of the multiplication, and I've plotted them and connected them in the same order, A, B, C, D, E, F, G, and you can see my shape, my little spiral shape, and you can imagine that original shape rotate it to the left 90 degrees about the origin, about the point 0, 0, and you'll get this shape. So that's how that rotation works. The matrix multiplication actually produces a rotation. Part 2 of this part of the project is kind of a mystery. You're going to try to figure out on your own what matrix causes a clockwise rotation. So I'm not going to tell you how to do that. You guys will figure it out. In the last part, you're asked to make a rotation of an arbitrary angle. Now I've picked 45, so it's too late. You can't pick that. What you're going to have to do is calculate the cosine and the sine of 45 degrees. Be sure your calculator is in degree mode, and then just ask it what it is. And as you can see, for 45 degrees, they both come out to be the same, 0.707. That's not going to probably happen for the angle that you choose, but that's okay. You get two different answers. And then just plug those things into the matrix as I've asked you to. As it's shown in the project sheet, you'll figure out how to plug it in. In my case, it came out to be 0.707, negative 0.707, and then 0.707, 0.707. And now I'm going to multiply my original point matrix by this and see where that takes me. As you can see, the result of that multiplication is pretty messy, and that's not a surprise considering that what I was starting with was a bunch of decimals in my R45 matrix. I put a 45 as the subscript just to remember that it was a rotation by 45 degrees. Alright, so I get all these crazy decimals. You can round off as I have to the nearest hundredth or thousandth. That's fine. And now my job is to plot that collection of wacky points. And yes, I'm going to have to approximate on my graph a little bit because they're decimals. You could use a graphing software to do this graph, and in fact, the shape is only going to look as good as your accuracy allows it to. You'll see that mine, since I've just sketched it out on the whiteboard, is kind of frumpy looking. You could do better if you took more time to do it than I did, or if you use a graphing software like Excel or anything that is handy for you. Anyway, here's what that looks like. At the top is the original, and at the bottom, I've plotted the points that I figured out for multiplying R45 times A. And it's not too bad. You can see the shape. You can see that it's been rotated about 45 degrees. I got a couple of points that are right there on the y-axis, which is what we might expect after a 45-degree rotation. And the whole thing is pretty recognizable. Okay? So that was the idea in the last part of part 3. Alright guys, well good luck. I know you only have 4 days this week in which to work on this. but I am also not asking you to do a MathMate sheet this week. Please, please, please contact me early and often if you have any trouble. I'll answer you as soon as I can. Don't forget to submit your project through Blackboard by Friday.